class. I found some time to make this quick video just showing you what it's like to convert from inequality to interval notation. And I've got some new tech at school, so I'm kind of trying to work it out. It's been years since I've worked one of these smart slates, so I'm a little glitchy. Please bear with me, but I think this will do the trick, and it's the only time I have to get this done. So interval notation is going to be right here what it says. I've got small comma big in this general area right here. So you're going to have two numbers. The smallest number always goes on the left. The biggest number always goes on the right. And on the outside of the small comma big, you either need to choose parentheses or brackets or one of each. It doesn't need to match. So if you choose kind of soft, curvy parentheses, it does not include the number. But if you choose the hard brackets, you are including the actual number. So I've got the only 5 examples you could even come up with. I've got one of each, and hopefully this will help you do those questions from 10.1. And like I said in my email yesterday, if you are moving on to college algebra, pre-calc, calc, interval notation is the standard, which was why I was so shocked when I saw in chapter 7 that they were not introducing that. And I just thought it was a weird MyMathLab glitch, or I would have done this a long time ago. So x is less than or equal to 8. So our biggest number here that it could possibly be is 8. 8 is the biggest. So 8 is the biggest, and it's going to be anything smaller than that. Since it is a less than, oh, it's supposed to be less than or equal to. Since it's a less than or equal to situation, then it's going to be 8 on the right-hand side because 8 is the biggest, and we're going to have a hard bracket on this side. And then it could be anything smaller than that. Literally, there's no end to how small it could be. So it's going to go all the way down to negative infinity. So that's our smallest amount. And since you can never quite get to infinity, positive or negative, infinity is always going to have a soft-sided parenthesis near it. It's never going to be a bracket. All right, number 2. X is in between -2 and 10, or it's greater than and equal to -2, but less than 10, and there's no equal piece here. So my two numbers, smallest to biggest, it's kind of bound, -2, comma 10. It does not include 10, so you do a soft-sided parenthesis, but it does include -2, so we're going to do a bracket. Number 3, x is less than -5. Very similar to 8, where you're going to be less than forever and ever and ever. So you're going to start off here with a negative infinity, comma, the biggest number it could ever be is a -5. There is no line here, so it does not include -5. So you're going to have a soft parenthesis there, and anytime you have infinity, you're going to have a soft parenthesis there. All right, I'm trying to get this to scroll. Yay, here we go. All right, let's look at the greater than. So now if x is greater than or equal to 2, 2 is actually the smallest value. It's anything greater, anything greater than. I got to figure out how to erase that real quick. There we go. All right. So anything greater than 2, so we're going to have 2, and then there's no bound to how big it can get. So it's going to go all the way up to infinity. Since it includes the number 2, you put a bracket. And since you can never reach infinity, you put a parenthesis. Super similar with question 5. -17 is as small as it can get. It's going to get bigger and bigger and bigger till you hit infinity. You never reach infinity. And we're not including -17, so we have a bracket right there. So if you can get your domain into inequality form, then you can translate that pretty quickly into interval notation. If it's all real numbers, if it is an all real numbers situation, it just goes negative infinity to infinity. And so anytime you get all reals, for instance, in the section you're looking at, anytime that is an odd root, anything under here, there's no restrictions to what that domain can be. This is again from section 10.1. And so you would have a negative infinity to infinity situation. You only really have to worry about the domain if the root right here, that little number right there, is an even number. You can tell by my handwriting I'm not quite perfected here yet, but I will get better with practice. All right, that's that. Good luck on your homework. Hope you all are doing well. And I'm working on the Chapter 10 review right now. So thanks so much.